Hello student, welcome back to ALC class, Automata language and computation. And today we are going to see the unit 1 DFA, Deterministic Finite Automata. Before seeing this, first we will go to the previous slides, then we will see what we have done in the last class. Okay, so let's go back. So here we saw the introduction in the last class, okay, in the previous class, and we see what is automata theory and what is the finite number of states. Finite number of state is, I told you about this one, okay. Ink color will be blue, okay. So this is, I told you, this is a finite automation, and after that I took the example of ATM, okay, and I told you the ATM is automatically, it will take the input, okay, it will take the input and do some thinking on performance, and it will give you yes or no. Means your program or whatever the thing you are doing, that will be accept or not accept, okay, that thing we saw. And in the formal definition of finite automata, whenever you go to the finite automata, there is a q sigma delta q0 f. This is a 5 tuple. Based on this only you can draw the transition table. I will change the color, then it will easy to recognize you. I will take red. Transition table, and you can make the transition graph, okay, with the help of this 5 tuples. So what is the Q? Quickly review, because in DFA also we are going to see these same tuples. Q is a finite number of state like this, and sigma is a finite set of symbol called the alphabet of the automation, okay, like alphabets, whatever you are taking from A, B, C, or 0, 1, small a, b, c, or whatever you are taking, that is called alphabet, and that is a sigma. And here the delta is a transition function. In DFA and NFA there is a different transition. What are the different transitions are there? We will see that. Fourth one is a Q naught, okay. What is Q naught? Is initial state from where any input is processed. Q naught belongs to Q. What does it mean? This mean is whatever the alphabets are available in the sigma or in the finite state. These are the finite state, 0, 1, 2, 3, like that. So here that should be belongs to Q naught. You cannot take, like here, take the example 0, 1. So you cannot take the initial state. You should take Q0 like this, okay. You cannot take some other elements. So here Q naught is the initial state. How will you represent? Like this, okay. Q naught, circle and single arrow, okay. F is a set of final state or states of Q of F subset of Q. So how we will define the final state? Double circle is a final state, okay. So this is a finite state automation. Then we saw what is alphabet. Alphabet is whatever you are taking here, that is all are alphabets, A, B, C, or 1, 2, 3, whatever you want to take. And what is a string? We can generate the string with the help of alphabets. A string is a finite sequence of symbol taken from sigma. So whatever the text, whatever the alphabets are available in the sigma, only that will be, with the help of that only you can create the string. You cannot add some new element like I shown you in the last class. E is not available here, so this string will not accept. Okay. Next, here length of the string. What is the length of the string? That is also a important thing. So here 1 2 3 4 5 6. So here the length of the string is 6. So how it will be denoted? As mod s called length of the string, and only s is a string. Okay, and this is a 2 level. I shown you this is a 2 level string, and this is a 4 level string. Like that you can create any number of 6th level string, means that will be a b b example, and you need to take only this element sigma alphabets, only this sigma alphabet you need to take, and you need to create the string. So this is a 6th level string. Okay, and empty string will denoted by lambda or epsilon. The two things, whenever you see lambda or epsilon, that means that is a empty string. What is empty string? Sigma is equals to empty bracket. This is a empty string. You will not have any alphabet in the sigma. Okay, keen star we saw. What is the keen star? Keen star we will get the infinite set of all possible strings. Like here we are telling 2 4 6, okay, levels. So here we will get, with the help of keen star, we will get all possible infinite set of all possible string of all possible length. Okay, and it will include the lambda. Lambda is nothing but empty string, empty string. Okay, and this keen star start from sigma 0. Sigma 0 is AB. Okay, sigma 1. What is sigma 1? We can make with this sigma AA, AB, BA, BB. This is a 2 level. Sigma 2, AAA, AAB. What is this? This is a 3 level. Then 4, 5, 6. You can make number of possible strings. So because of that, sigma 0 union, sigma 1 union, sigma 2 union, so on, where epsilon sigma p is a set of all possible string of the length p. So how many possible string of length p it will display, it will represent with the help of this. Okay, so this is a keen star. So how, here the example, sigma is equals to a comma b, then sigma into sigma star is equals to lambda a comma b comma aa comma ab comma ba comma bb comma aaa comma aab, then next is abb. Like this you will get all possible string of all possible length. This is a 1 length, this is a 2, this is a 3, then we will get a, this is a 4. Okay, so like this you will get all possible string of all possible length over sigma. Okay, over sigma. Okay, next, keen closure or keen plus. What is this? Sigma plus is an infinite set of all possible string of all possible length over sigma. This will also will get all possible string of all possible length over sigma. What is the thing? It is removing the lambda, it is removing the lambda, and as well as sigma 0 is also not including, it is excluding, okay. Sigma 0 is excluding and excluding lambda, this two thing is excluding, then we are getting the sigma plus, sigma 1 union sigma 2 union sigma 3 so on. Sigma plus is equals to sigma star minus lambda. When you remove the lambda, then sigma is equals to a comma b, sigma plus is equals to a comma b comma then a b. So here can you see this, here the lambda is added, but here there is no lambda, so key closure or key plus does not include the lambda. Okay, prefix and suffix we saw in the last class. This all things we done because of some voice problem. Once again I am explaining you this, okay. So prefix string is nothing but like if you have a string like this ABC string is there, so first will be epsilon and whatever the first from the left we will add, then next AB, then ABC. This is string, we are preferring the prefix, okay. In the same way suffix, what is suffix? Suffix of the string is, if we have the ABC, so we will like see here epsilon comma at the right side, the first letter from the right is C, then again BC, then ABC. So this is a what is this? This is a suffix, 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 and this is prefix, okay, fine. So this is a thing in prefix and suffix. Next, language. In the definition of language, what is language? Language is not a programming language like C, C++, and Java and something like that. Language is nothing but it is a set of string or it is a string, okay. A language is a subset of key star for some alphabet sigma. It can be finite or infinite. A language is a subset of key star for some alphabet sigma. It can be finite or infinite. So here if the language taken all possible string of length 2 over sigma, so we will get this value. Only just we want the level 2 of sigma a comma b, okay. So if in place of this 2, if it is telling length 3, so we need to get the value like 3, this, okay. Like that we can do the infinite number of possible of the given length. Clear? So this is a definition language, okay. So today's class we are going to see the finite automata. This is a today class. Finite automation can be classified into two types. Don't think I did the spelling mistake. This is different, and AUTOMATION, this is different. Both are different. This one and this one is different meaning. Finite automata is singular of finite automation is a singular part of finite automata. Okay, this is plural is automata. Automata. Okay, so this is automation. Can be classified into two types: deterministic finite automation, non-deterministic finite automation. Okay, so only today we are going to see this part, only this will be in the next class. Okay, so today we are going to see only determinist. This one, finite automata, can be deterministic finite automation, DFA. Okay, now this is very important. Based on this only all the unit is depend, like you must know what is DFA and what is NFA. Okay, in DFA, for each input symbol, one can determine the state to which the machine will move. Hence, it is called deterministic automation. What does this mean? For each input symbol, one can determine the state to which the machine will move. Hence, it is called a deterministic automation. In next slide, you will see the diagram of finite transition graph. There you can easily understand the meaning of this. Okay, for each input symbol, one can determine the state to which the machine will move. Hence, it is called deterministic automation. Like ATM, okay, one can determine the state. So here, input, here yes or no, same thing. But how? In the form of transition, this is an example. Okay, but how in the transition graph and transition table we will see. Okay, as it has a finite number of state, the machine is called deterministic finite machine or deterministic finite automation. Okay, so this is a DFA. In this you will get the finite number of states. Here also, as I told you, in the FA, finite automata, in FA, we saw the 5 tuples. Did you remember 5 tuples? The same 5 tuples will be there for determining the finite automata, deterministic finite automata. So here, Q, sigma, delta, Q0 and F. Okay, what the Q is a finite set of state. Finite set of state means that should not be an infinite, as I shown you, sigma 0 comma 1. Okay, so whatever the finite states, that is set of states, that should not be a more infinite set of state. Sigma is a finite set of symbols called alphabet. So whatever here, this called a set of symbols called the alphabet. This all the symbols like 0, 1, or you can see A, B, C. Okay, fine. Here, delta is a transition function where delta Q cross sigma to Q. Okay, what is this? We will, like here, Q cross sigma. So whenever you want the transition, you must do some operation on this 2, then only you will get the transition. Okay, that also we will see in today's class, transition table or and graph. Okay, Q0 is the initial state from where any input is processed. Like Q0 belongs to Q. Okay, Q0 should be belongs to Q. F is a set of final state, or QF subset of Q. So what is the how to represent the initial state? Initial state will be like single arrow, and this is circle called state. State, if you have like this with the empty, then it is a initial state, and the final state is double circle, you can say F. Okay, final state, this is a final state. Final state. So this is how many tuples are there to do some operation on the finite automata. 5 tuples, capital Q, sigma, delta, Q0 and F. Here, graphical representation of DFA. What is the graphical representation? Like this graphical representation, before going to this, just you need to know what we are going to do in the graphical representation. A DFA is represented by a digraph like this, okay, here let's see, okay, called state diagram or transition diagram. There is a two name of the DFA representing the digraph, that is a state diagram or transition diagram. Next, the vertical representation, the states. Okay, vertical representation is states like this, vertical. The arcs labeled with an input alphabet shows the transition. Transition means, like, take the example of Q0, and this is the initial state. If you forget to add this initial state, then your all DFA will be the wrong. Okay, take here Q1, and this is the final state, and here 0, 1, and take here 0, 0, and here the 1. Okay, this is the arc label with an input alphabet shows the transition. So can you see this alphabet 0, 1, and I draw this sigma is equals to 0, 1. My string was this. Okay, so 0, 1, 0, 1. So whatever it is written here, this is called labeled. Okay, this is called labeled. Okay, the initial state is denoted by empty single incoming arc. Single incoming arc. You cannot give like double arrow Q0. This is wrong. This is wrong. That should be a single Q. This is valid. Okay. The finite state is indicated by double circle. As I told you, double circle, this one. This is a final state. I hope you understand this. Fine. So we will take one example. We will take the example. Let a deterministic finite automata by Q is ABC, okay, and the sigma is 0, 1, and Q is equals to A, and what is F is equals to C. So what we have, 5 tuples here. What is our 5 tuples? Q, sigma, delta here, delta, then Q0 and final. So these are the things. So we have Q, sigma, Q0 and F. Delta, transition function delta as shown by the following table. So here the table, okay, here its graphical representation word as as follows: transition function delta as shown by the following table, and this is what is A, B, C. A, B, C. What is this A, B, C? A, B, C is nothing but Q, this one. Okay. Now, and what is this 0, 1? What is this 0, 1? 0, 1 is this. So, with the help of Q and sigma, we will get the delta like this. Can you see this? Q cross sigma. Q cross sigma is Q means ABC. This is Q and Q and sigma. Sigma means 0, 1. Sigma 0, 1. So now here, with the help of this, we can get the graph. So already predefined the data available is here. From A, if the value is 0, then it is going to A, C, B, and here if it is 1, B, A, C. So while seeing this graph, while seeing the transition table, this is a transition table, okay, this is called transition table. Okay, so while seeing this, we need to draw the graph. We need to graph transition graph. We need to draw the transition graph. Okay, first here present state. What are the states? A, B, C. So first draw the circle A, B and C. Okay, in the initial state, initial will be like, it will denoted by arrow like this, and final state will denoted by star before the alphabet, before the symbol. Okay, so initial state is A. I am not defining this here. The mistake means the table is not here, so it is not mentioning the initial state and final state. Because of that, I selected here. So initial state is A and C is a final state. Okay, so now here from A to A to A is going when the 0 is occurring. So here A, the same is going here when it is 0, when the label is 0. Okay, when A is 1, where is going? B. When A is 1, is going to B. Okay, now the next one is B. B is going to C when it is 0. B is going to C when it is 0. Okay, now B is going to A when it is 1. Input is 1. B is going to A when the label is 1. Okay, next C. C is here. C is going to B when it is 0. Is 0. C here, C is going to C when the input is 1. So this is a transition graph for the given transition table. Okay, clear? Once again I will repeat this. Okay, the lambda, okay, here what we are doing, we are performing the delta. We are performing the delta. In the delta, q cross sigma, q cross sigma. So here first you need to write the state. This all we will call state, stat, and this is stat, and this is a stat. In this all it is, this is initial state. Why it is initial state? Because the empty single arc is giving to this state. Because of that, this is a initial state, and this is a normal state, normal, and this is a final state. Okay, final state with the double circle. Okay, so this is a graphical representation is like this. With the help of transition table we can make the graph, and with the help of transition graph we can make the transition table. This is a vice versa. Okay, next, here the table, what is this? This is the same table like this: present state PS, next state for the input 0, IP and IP, input 0, input 1, this, and what is this one? This one is a Q, and what is this? This one is sigma. Okay, so here while saying this we need to draw the, this is a transition table. Now we need to draw the transition graph. Okay, we will see the transition graph. Okay, first A, B, C, D. How many are there? A, B, C, D. So here we will take A state, B state, C state, and here the D. Here we need to write the D. A, B, C, D. What is this? This is a Q. What is Q? Finite set of state. So I have 4. Now here which one is the initial state? C, B, D, A. Which one is the initial state? With the help of transition table, can you see here? This is a initial state. Initial state will represent as single arc arrow, okay, to A. Okay, and what is the final state? Final state is this. It will represent as star. So how we will represent in the state graph? Double arrow. We can say transition graph or state graph. This is transition table or state table, anything you can say. So here A, So we got, first is we got the Q, okay, A, B, C, D. Then after that we found, means we get the data from the transition table, initial state and final state. Okay, now from A, if it is 0, where it is going? It is going to C. A is going to C. A is going to C when the input is 0. When input is 0, A is going to C. Okay, next. A is going to B. A is going to B when the label is 1. When the input is 1. A is going to B when the label or input is 1. Okay, so this is finished. Next, B. From B to C is going from B to C when it is going to C when the input is 0. B is going to C when the input is 0. Okay, now this is also finished. Next, B to B going when the 1 is there, 1 input. So B to B, like this loop, B to B is 1. When the 1 is there, is going B to B. Okay, next is going to C. From C to C is going from C to C when the 0. So this is 0. When it is 0, it is going to C. This is finished. Then C to D is going when it is 1. When it is 1. Okay, so this is also finished. Next, D. From D to D is going 0, and again D is going to D even though it is 1. So D is going, if it is 0 or 1, is going to D only. Okay, so this is a state graph. Don't get confused between state graph and transition graph, both are same. Transition graph. So I hope you clear this. Once again I will quick tell you about this. This is a transition table. Okay, in the transition table we have the Q, A, B, C, D. Okay, and this will indicate the initial state and this will indicate is a final state. Okay, and here the input 0 and input 1, this is a sigma. Okay, if it is A, from A to C, if it is going from A to C is going when it is 0, the input is 0, from A to C is going. Okay, from A to B is going whenever the input is 1. From A to B is 1. Okay, in the same way B, from B to C is going when the input is 0. Input is 0. B to B is going when the input is 1. Okay, next one is C. It's going from C to C when it is 0. Okay, and C is going to D when, from C to D is going when the input is 1. Here the last is D from D is going to D when it is 0 or 1, D, D. So this is also finished. With the help of transition table, we develop, we design, we draw the transition graph. Okay. Okay. So this is an important thing. Okay. Now we will see the acceptance of the string by finite automata. What is this acceptance of the string by the finite automata? Means whatever the string you are passing, that is accepting by the FA or not. We need to check. How we will check, I will show you. Okay. So here, so this is already the diagram is here. So I will do one thing. Fine. We need to write here. Okay. So quickly I will write the string, string string. What is a string? 1 1 1 1 0 1 0. This is a string. Okay. And we have the graph, this one. Okay, we will draw quickly here. A, B, C. This is initial state, this is normal state, and this is a final state. And here is the initial state representation. Okay, how? If it is 0 is going to A and B. This 0 and here the 1. Okay, B is going 1 here and 0 is going there. From B, if it is 0, it is going to C. If it is 1, is coming back to 1. Okay, C. What is C? C, if it is 1 here, 0 is going back. 0 0, and if it is 1 1. Okay, fine. So this is a graph. This is a graph. So here we need to see the acceptance of the string. Okay, we need to see the acceptance of a string. So first thing we need to do here, what is the initial state here? Initial state is initial state. Which one is the initial state? Initial state is A. So write the A. And what is our string? String is this. I will do one thing. I will change the color. Okay. So what is a string? String is 1 1 1 1 0 1 0. Okay, so this is a string. First we write the initial state. Okay, and we will write the string. Now here A is 1. Okay, if A is 1, where it is going? If A is 1, then where is going? Is going to B. So you need to write here B, comma, you need to remove this one. You need to remove this one because we reached here. Remove. Okay. So B, comma, 1 0 1 0. Okay. 1010, checking the, what we are doing here, checking the string, okay. Now b comma 1010, next is b. If b is 1, where it is going? If b, this one, b is 1, is going to a. So here a comma, we need to remove this one, we need to remove this, then so what will be the answer? What is the remaining string? 0 1 0, okay, 0 1 0, fine. So this is the remaining string. Now check, if a is 0, where it is going? A is 0, a is 0, 0 means it is going to a only. So this is a, and here we need to remove this one, okay, and here remaining string as it is 1 0. Next, here a, if a is 1, where it is going? If a is 1, is going to b. So you need to write here b, okay, b comma, you need to remove this one because already we reached there, because of that we are removing that. So here what is the remaining string? We have 0 only. Now the next one is if b comma 0, if b is 0, where it is going? Going to c here. So write the c and check the remaining string. We don't have any remaining string, so bracket close, this also need to remove, okay. So what is our final state? Is C. So what the answer we are getting here? This is answer, ANSWER. So that means it is accepting. After checking, okay, given string we are checking, after checking we are getting the final state. That means this string is valid, okay, valid or accepting the given graph. Okay, whatever the string is given, that string is accepting by this state graph. Clear? Once again I will just quickly tell you about this. A, why we are writing this? This is a initial state and here string. Okay, initial state. What is initial state here? First a comma, string is 11010, and here if a is 1, where it is going? The arrow is going to b. So wherever it is going, just write that one, b, okay, and remove this one from the string, write the remaining string here, 1010. If b is 1, okay, where it is going? Again it is going to a. So write the A and remove this 1 and write the remaining 0 1 0. Okay, remaining string, remaining string. Like that. If A is 0, where it is going to A. So we are writing A and removing this 0 and writing the remaining string here. Okay, next, if A is 1, where it is going to B. Okay, we are writing the B and removing this 1 and writing the remaining string. If B is 0, where it is going to C. We are writing the 0 and this C, and we are removing the 0 and writing the remaining string. We don't have anything, so this is your final answer, and the given string is accepting. Okay, clear about this? Accepting. So this is about this string. So one more thing, here we have another string 1101001 is accepted by the FA or not. We need to check on the same graph. Okay, let's see. Fine. First I will do one thing. Okay, fine, no problem. Here only I will explain you. Here, first thing, what is our initial state? First is initial state is A, comma, and we are writing the string 11010001. Okay. Here, if A is 1, where it is going? If A is 1, is going to B, comma 101001. Okay. So we are removing this one. Okay, remaining string we are writing as it is. Okay, the next one is B is going to 1. If B is 1, where it is going? B is 1, so it is going to A, comma 01001. So we need to remove this. This one we are removing. Okay, and remaining string we are writing as it is. Okay, the next, if A is 0, where it is going? If A is 0, where it is going? Again it is going to A only, A comma, then here we need to remove this because we reached here. Okay, in this 1001, we are writing the remaining string. Okay, next, if A is 1, where it is going? Is going to B, and we need to remove that 1 from the above list, and we need to write the remaining string. here b comma 0 0 1. Okay, next if b comma 0 0 1, so b is 0. If b is 0, where it is going? B is 0 is going to C. B is 0 is going to C comma, we need to remove this 0, okay, and you need to come back C comma 0 1. We wrote the remaining string. Now again C is 0. If C is 0, where it is going? Is going to B comma, you need to remove that 0, remove that 0, close, okay. So if C is 0, we are getting the value B, okay, we are getting the symbol B, B comma, remaining string is 1, okay. Now B comma 1, if B is 1, where it is going? If B is 1, is going to A. A means if B is going to 1, we are getting the value A. Then we need to remove this string and you need to write the remaining string. But we don't have any remaining string here. Because of that, this is your final answer. Final answer. Okay. And this, what is our initial state? Is A. What is our final state? Is C. But what the answer we are getting? A. That means this string is not accepting. This string is not accepting on the given graph. Clear? Did you understand this? This is very simple. Acceptance of the string by finite automata. This is a one string and this is one string, and this whole string we applied on the given graph and we got the result. Okay. First string is accepting, okay, and here in the second string is not accepting. This is accepting. Okay, fine. So today's is this class. Quickly I will review what we have done today. We saw the two types of DFA and NFA. Just we studied only DFA, okay, and we saw the DFA symbol, okay, what is deterministic and DFM, and here the 5 tuples are there: Q, sigma, delta, Q0 and F. Okay, Q is a finite set of state, sigma is a symbol called the alphabets, okay, and delta is the transition function, and there should be a Q cross sigma. Okay, remember this, because in NFA the formula will be different, so remember this, Q cross sigma. Q0 is the initial state from where any input is processed. Q0 belongs to Q. This should be, Q0 should be belongs to this, okay, Q, and the final state will represent as finite double circle, finite state, and initial state will represent as in this format. Okay, and this is a state diagram or transition diagram. Fine. So this is, we took the example Q ABC, sigma 0 comma 1, Q0 is equals to A, F is equals to C, okay, and we perform some operation. This is a transition table. We used to say this is a transition table, and this is, we used to say, transition graph. And here draw the transition graph for the given transition table is this. This is the table, okay, and based on this table we draw the transition graph, okay, and we saw the acceptance string, okay. So here we took the string and we solved and we saw which string is accepting. This string is accepting and this is not accepting, okay, fine. So in the next class we will see the next method of next way to do the finite automata, okay, automation, non-deterministic finite automata. And if you have any question, any problem, any question you want to ask, you can message me on WhatsApp, any doubt, that also it will be easy for you to clarify your doubt. Otherwise, when we take the Zoom meeting face to face, at the time we can also solve. If you have any doubt related to this class, just message me on WhatsApp at the time of Zoom meeting. That will be easy for you to remember what question do you want to ask me, okay. Thank you.